Hi there and welcome to video lesson 5.3b. There are two goals in this lesson. However, this video will be focusing on goal 2. The goal for this lesson is I can graph an equation when it is written in slope-intercept form. Now, when an equation is written in slope-intercept form, it is really easy to locate the slope and the y-intercept. And if you know both the slope and the y-intercept, it's very easy to graph the equation. So let's take a look at a linear equation. Y equals 3/4 x minus 2. If you can identify the slope and you know what the y-intercept is, you can use those two pieces of information to easily graph. So we know that this linear equation is a line that has an infinite number of points. You also know that this line has to cross through the y-axis at -2. So that has to be one of the points along the line. Well, knowing that, I could go down the y-axis and I could plot a point right here at -2 because I know the line has to go through that point. Well, to make a line, I need at least one other point. What other information do I have? The slope. The slope is rise over run. If I start at the point that I've just plotted right here and I rise up 3 and then I run over 4 and make another point, I could connect those 2 points to make a line. And this is how you graph the equation when it's written in slope-intercept form. So much easier than when we were making a table of values in chapter 4. I bet you could agree. So let's give this a try. Let's go through a few examples that you will find in your notes. We're going to start with number 4. Now on number 4, I wanted to revisit the invisible slope, which is the slope that we can't see. And you already probably know what that's going to be, but I wanted to practice graphing this with you. So go ahead and write down these two equations for number 4, okay? Now we have to start by graphing the y-intercept because we have to start with a point. We just can't go making a slope anywhere we want. So right here I can see that the y-intercept of this line is at -5. So I'm going to go down the y-axis, make a point at -5. There we go. Now I'm going to make some additional points using the slope. There's not a number in front of the x. You know that it's invisible. It's a 1. Therefore, the slope is 1. Now remember, slope is a ratio of rise to run. It's a fraction. So if I write this as a fraction, 1 over 1, now I have a rise and I also have a run. So I'm going to start back at this point that I plotted at -5, and I'm going to rise up 1 and run 1 to the right to make it positive. Up 1, right 1, up 1, right 1. I can continue doing that as long as I want to. And when I connect the points, I will have the linear equation that has a y-intercept of -5 and a slope of 1. Let's try the next one. On this next one here, I can see that the y-intercept is at +2. So I'm going to drive up the y-axis at +2. I'm going to make a point. This line has to go through that point. It has to cross through at that y-intercept. Now, for the slope, I know that there's an invisible 1 right here. I'm going to make that into a fraction, 1 over 1. We know that it's negative, okay? I'm going to think rise over run. So when I go up to my y-intercept, I'm still going to rise up 1, but instead of running to the right, I'm going to run to the left in the negative direction and make a point. Rise 1, left 1, up 1, left 1, up 1, left 1. And I can continue doing that. Then I'm going to connect the points here and graph the line. So here I can see I have the intercept of +2, but I have a downward falling slope this time of -1. Okay, so this is just an example of those invisible slopes that of 1 and -1. Okay, here's number 5. Go ahead and write down this linear equation. Now, you might recall that it's in a different form from our lesson the other day. It absolutely is. It's not y equals mx plus b, which is going to make it kind of hard to graph at this point. It's actually in standard form. So let's rewrite it so that it is written in the form that we're familiar with, y equals mx plus b. So I'm going to put a line down here, and we're just going to kind of recall what we did the other day, box up that y. Remember, we want to subtract 6x. I need you doing this with me. That crosses out. We get 2y. Now remember, these two need to be in the certain order. We want the mx, the term with the x, to come first. And then the +8 is going to come second. Now our last step would be to divide by 2 And then we want to divide everything on this side by 2. I would suggest doing a slope and intercept separately. That way the slope is going to pop out to you really nicely, -3. Drop down the x, and the y-intercept will pop out really nicely to you also, +4. Okay, so now we have the equation in a form in which we're familiar with. All right, let's begin to graph. So first thing we need to do is to locate the y-intercept, and that is at +4. So we know that that has to be a point. You have to have a starting point. That's going to be it. So +4 on the y-axis. Now we have a slope of -3. Remember, slope is a ratio of rise over run. I would make this a fraction so it's a little bit easier to see. It's negative, so we want this line to fall. So rise 3, run 1. I'm always going to go up for my rise. I'm going to rise 3 from the point I already have, 1, 2, 3, but to make it negative, I run to the left in the negative direction. Now you could do the opposite. Instead of rising 3, I could fall 3, 1, 2, 3, but then I would have to run to the right. You're just doing the opposite. Then you can connect your points here, and you'll see that you have an intercept at +4 and a nice slope that's falling of -3. All right, so this one we had to convert. Number 6, copy it down. Same thing, we're going to need to do some converting. I will be teaching you how to graph with standard form, but not yet. All right, let's get ready to convert. Line right down the equal sign, put a box around the y. I'm telling you, this is going to get easier the more that you do it. We're going to be doing this a lot. Let's take away the 5x, drop down the 2y. We want these in that particular order, the mx first. Oh, I just wrote m. And then +6. Okay, then everything gets divided by 2, so that way we have the y by itself. Both slope and intercept divided by 2. Now the slope's going to pop out to you really nicely here. It's -5/2, drop down the x, and the intercept also looks like it's going to be +3 when you divide. So here is our equation. It's equivalent to this first one. It's just written in a different form. Okay, so first things first, we need to have a starting point. The starting point is going to be your y-intercept. So find +3. Whoop, there it is. Make a point. Now we want additional points using our slope. Okay, so we've got a negative slope, so keep that in mind. Rise is 5, run is 2. I'm going to rise up 5. So 1, 2, 3, 4, 5. Oh, I'm off the graph. Now my run is 2. I want it to go to the left. So I rise up 5. And if I run 2 to the left, I'm off the graph. Now, if you try graphing this on a computer and put a dot off the graph, it's not going to be able to locate that dot. So I'm going to have to do something different. Instead of rising 5, I'm going to have to do the opposite. I'm going to have to fall 5. So let's fall 5. 1, 2, 3, 4, 5, which means I'm going to have to do the opposite of run. On my run, instead of left, I'm going to have to go to the right 2. Now, do you see what happened here? Now I'm on the graph. I could fall again, 1, 2, 3, 4, 5, and 2 to the right. And I'm still going to have a line. Nice line. Okay, negative slope, the line is falling. And it's got a slope, rise 5, run 2. Okay, there we go. So if you're off the graph, you need to get back on the graph. You might have to fall, and that works too. All right, number 7. Copy down this equation. After this one, we got a couple special cases. Okay, so we're going to rewrite it. Let's rewrite it. We don't want it looking like this. Okay, we want to get the y by itself, so let's take away the x on both sides. Remember, if I'm moving too quick, you can always pause the video. So we're going to drop down -3y, 15 minus x. I don't like that. We want minus x first and then plus 15. There we go. Now we're going to have to divide by -3 everywhere. Divide by -3, divide by -3. Okay, this is a good one. There's an invisible number in front of this x. It's not just negative, it's -1. It might be helpful to put that. What's your slope going to be? -1 divided by -3, that makes a +1/3. Drop the x. Intercept. Signs disagree. Divide, -5. There we've got the equation of our line. Okay, we've got to graph it. We need a starting point. What's your starting point going to be? Yep, it's your y-intercept. Find it all the way down here. It's going to cross the y-axis at -5. Now we want to make additional points using the slope. Slope is nice here. It's 1/3. So I'm going to rise 1, run 3. up 1, to the right 3, up 1, to the right 3. And then I can just simply connect the points. And there I've got the line. Okay, pretty simple, pretty fun actually. Number 8, here we got our special case. Now this equation only has a y equals 5. That's it. Okay. Well, remember, equations come from y equals mx plus b, right? And you see here that the x disappeared. So what number would have had to be multiplied to this x to make it just disappear? Well, that would have to be 0, right? 0. 0 times x would be 0 and it would go away, which means that this 5 is actually the y-intercept. Now think about if I were to simplify this equation. 0 times x is just 0, so that would go away and I would end up with just y equals 5, which is what I gave you in the beginning, okay? But you need the slope and the y-intercept to help graph it, so that's why I kind of just broke it apart again. All right, so y-intercept at 5, right up here, and a slope of 0. Remember, 0 has no steepness. That's a slope that just simply looks like this, flat. So my flat slope just like this. Now, if I need to graph another point, I sure can. I can graph this point and I could graph another point like right here or anywhere, and it will make that line if I'm doing it on a computer. Okay, now notice here, this equation only has a y in it. And do you see how it only crosses through the y-axis? It will never touch the x-axis because it doesn't have an x in it. All right, so that's just going to be a horizontal line. Slope of 0. This one, now this is something you haven't seen before. X equals -3. Now, this one only has an x in it. That means it can only touch the x-axis. Where can it touch the x-axis? Well, it says x equals -3. It's going to cut through the x-axis, and that's it. Now, the rule says x equals -3. So think about back in chapter 4 when we made a table of values. If the rule says x equals -3, that means x is always going to equal -3. No matter what the y value is, x is always -3. I mean, I could have any number here for y. I could have 4, I could have -2, I could have -6, anything. Though x is always going to be -3. Now, it can only pass through the x-axis. So if it can only touch the x-axis and never the y, that means it's going to have to be vertical, right? So if I graph a line that's vertical and touches the x-axis at -3, here's the x-axis, here's -3. If it goes vertical just like this, do you notice how it's going to have an undefined slope? Yeah, it only goes through the x-axis at -3. Now let me show you how these points are actually on the line. -3, 4. That'd be -3 up 4. Boom, there it is. -3, -2. -3, -2 right here. -3, -6, -3, -6 right here. See that? So these can be kind of tricky. Just think it only has an x in it, so it can only touch the x-axis, and it's going to touch it at -3. It's going to have to be vertical. Kind of tricky, but we'll be working more with it as we go along. Now, this last one here is not on your notes. I just want to quick talk about it. What if I gave you an equation like this? Now, remember the very first thing you want to graph is the y-intercept. Do you see a y-intercept? No, it's missing that second number, right? Well, what would the y-intercept be if it's not there? What number would that be that represents nothing? Yep, a 0. This is a direct variation, y equals kx, right? And we know direct variations always go through the origin, and that's why this is going to start at 0. And then, of course, I would just make another point using my slope of 3/4 up 3 over 4 and connect the points and graph them. So if you don't see an intercept, it's 0. It's a direct variation. It goes through the origin, just like that. Okay, now let's go to our summary. All right, in our summary, there are 3 steps to graph an equation in slope-intercept form. The first thing that we needed to do was to be sure that the equation is written y equals mx plus b. So if it is not, we want to convert it and change it. That way we can easily locate the slope and the y-intercept. That would be our first step. Then the second step was to plot a point. Where are we going to get the point from? Well, the point that we're going to use is the y-intercept. So we want to plot that y-intercept right on the y-axis. Remember, that's the b value. And lastly, we want to make additional points using the slope. And if we do these 3 things, we can easily graph any equation that's written in slope-intercept form. Thank you so much for joining me. I hope that this video was helpful. Have a great day.